This event is the culmination of a 3-day set of exercises. We've done 2 days of technical continuum where we've had 30 short focused talks by faculty and students about projects that they're working on or would like to work on.
Sometimes what happens is you get these people who might not have otherwise had a working relationship with one another from a collaboration point of view, come together and say, hey, I have an idea for that, and start something that's novel and innovative.
You get feedback, you get follow-on emails, and people present ideas that we hadn't thought of that we can then integrate into our project. Or they see something, maybe a specific element of this launcher that they say, hey, I can apply this to what we're currently trying to solve.
Being a distance learning student, I didn't have a good understanding of the real scope of the unmanned systems development. So being here at TechCon, one of the biggest things that I'm taking away is having an understanding of how many different projects like that are going on.
What I like to say about CRUSER is it allows us to bring people together to have that conversation. And so what I typically like to say is that conversation leads to collaboration and collaboration leads to innovation.
As a professor at NPS, nothing makes me more excited than to see our students all fired up about their thesis work and their class research. And several of the projects here are going to provide immediate application in the field environment, record-breaking applications for flying high numbers of small UAS systems in the airspace. So very excited about seeing that.
So what we have here is we're building a UAV launcher, and our goal is to make it capable of supporting swarm operations. In the sense of our Arsenal lab that we're working with, their goal is to have a 25v25 autonomous air war with these UAVs that you see launched there. They're called the Zephyr 2. The limitation they currently have is that the UAV has a 45-minute endurance. We want 50 aircraft airborne, and we'd like a 30-minute combat time. So in order to facilitate that, you have to get all the aircraft airborne in 15 minutes or 15 seconds per launch. Their current system uses a bungee that's 100 feet stretched out, and they're using an individual to go retrieve it each launch. It takes a minute to a minute and a half. So the team came to us and said, hey, how can we do this better? How can we get them airborne faster? So what we did is we went through a systems engineering process to kind of identify the needs of the stakeholder, the capability gaps and what they currently had, and then set out to figure out how can we fill those gaps and satisfy the stakeholder. From that perspective, we eventually arrived at this rolling chain type design. Uses an electric motor. It accelerates the assembly from 0 to 35 miles an hour. Our goal is to do it in about 8 feet, which is what you see here. Eventually, we'll continue using iterative prototyping to build technology in at each phase as we prove the basic technology or our key performance parameters. I did the mechanical design here. I had a partner, Lieutenant Livesay, and he did the key part that I think is the key technology of the future, and that's the electronics and the programming.
With this particular version, we're talking about using high voltages of 48 DC volts and currents of up to 400 peak amps. There's some unique challenges that come along with that, and we're hoping to overcome some of those challenges with electrical components, some relays. We're going to be hooking up microcontrollers. Hopefully we'll be able to drive it with something like a PS3 controller wirelessly via Bluetooth. So there's a lot of enabling technologies out there that already exist. We're just hoping to be able to draw from this and draw from that, bring it all together and put it into a nice package where all you have to do is flip the on button and everything auto boots, everything energizes the way it's supposed to, and all you have to do is turn the switch on and be able to drive it.
My capstone project was the 3rd phase of a 3-phase project to help improve the airworthiness process between NavAir, who is responsible for airworthiness for all naval aircraft, and Naval Postgraduate School, an organization that operates a lot of small UAVs as a part of their ongoing research. Probably one of the biggest things that opened my eyes is how the airworthiness process is not really equipped to handle the approval of airworthiness for unmanned aerial vehicles, especially small ones. The system is set up and has been set up for many years to approve the airworthiness of manned platforms such as F-18s and P-8s and other normal aircraft that we think about when we think about naval aviation. But the unmanned aerial vehicle brings unique capabilities and a unique situation into this mix that the system, the process, is not exactly adapted to yet. The nature of our project was to help identify where those barriers are and try to make some changes to that process to allow for a smoother approval of flight clearances for small unmanned aerial vehicles.
Previously, to reach out and touch you, it took a physical touch. Now, I can reach out and touch you from my living room. It's critically important, not only for infrastructure and commercial applications of that technology piece, also, in our case, the warfighter. It's how wars will be battled in the future, for sure.
We're working with teams at the Naval Academy, at 3rd Fleet down at Spa War Systems Center Pacific, and here on campus at the Naval Postgraduate School to explore the extent of robotic warfare, especially in robot-on-robot warfare, and where does ethics actually become involved in that?
At NPS, we've gathered together myself as a naval flight officer. We also have a Navy surface warfare officer and a Marine infantry officer. We were given a basic scenario of what a potential future war might look like for the use of robotics in the next 2 to 3 decades. The brainstorming process was fairly easy. We started with working out the crazy ideas and then determining what would be simplest and most flexible. Some of us were thinking in terms of technology, some of us think in terms of networks, some of us considered the political or the operational considerations. The benefit of having different perspectives is that we all came up with lots of ideas. Our ideas were financially and technologically feasible and thus most effective in future war and future peace.
Certainly the existence of UAVs in our future is an important one. There's a lot of talk, and has been a lot of talk, about UAVs over the past 10 years even, that they're going to replace manned vehicles and so on and so on. I don't think that's necessarily true. However, UAVs do bring unique capabilities into our military organization, and it will be important for future commanders to utilize those capabilities to their greatest extent, all the while utilizing manned vehicle capabilities to their maximum extent, where you will then have a synergy between the two. I think that's where our future lies, is a blend of both manned and unmanned technologies in order to have an efficient warfighting machine.